Hey everybody, my name is RSAXVC, and I'm going to give a short presentation. This is a tool talk on a particular Bluetooth low energy toolbox available for Android and iOS. The title of the talk is called Hacking Joel's Keys. One time I got bored in a meeting. This might happen slightly more than you might think. And so I pulled out my phone and I started scanning for Bluetooth devices. I'm like, let's see what we can talk to. I'm like, huh, what's this? That's a new thing. Yeah, I used to draw dinosaurs instead, but I got in trouble for that once at work. So this is our target device for today. It's not super complicated. It's a little Bluetooth low energy beacon. It connects to your phone. They're like, what, 20 bucks for 3 or something? It connects to your phone. You can hit a button on your phone and this beeps. Or you can hit the button on here and then your phone beeps, and that way you can not lose your keys or your backpack. And it has some other functionality, like if you walk away from your backpack, your phone can beep and tell you that you did that. So it's handy for stuff. So Joel's keys run Bluetooth, it turns out. Joel didn't want to lose his keys, so he attached one of these little beacons. Testing. Test. In particular, it's Bluetooth low energy, which is basically way different than standard Bluetooth, so if you know anything about that, don't think about it too hard. The key thing that we need to talk about real quick is this table. So a Bluetooth low energy device has this concept of services and characteristics. So a service is not like, it's actually really well done, but it's not like a service like Apache. A service in Bluetooth might be like the generic device service, and it might have a characteristic. The characteristic is more like a variable or a constant. So it might have a characteristic like the device name. Or you might have a battery service, because a lot of stuff has batteries, and it would have a characteristic like, say, the battery value in a %. So these are the common ways that you have services and characteristics. And you can have multiple characteristics in a service. Like the battery service we talked about is actually in a Bluetooth standard. The only required thing is that you have a battery level, but there's other stuff like if you want to tell people what the chemistry of your battery is, you can add a read-only characteristic to say that. So now you know how Bluetooth low energy works. That was basically like the back end of how every one of the apps on your phone talks to every one of your Bluetooth IoT devices. But that's not particularly helpful to someone like us who wants to play with stuff directly. Somebody wrote this tool, which I use all the time at work for actually like legitimate Bluetooth development. But also, like, I don't work in security, and this talk has nothing to do with what I do for work, which I should have prefaced this talk with. But basically, BLE Scanner is this handy little tool, and it lets us connect to a device and start just reading and writing stuff directly to its characteristics and services. So if we want to write our own client for something, we can prototype that really easily. BLE Scanner does not attack the Bluetooth stack itself. It just it basically implements the standard just really generically. So it doesn't do any sort of security stuff all by itself. The only thing you're going to use it for is application layer vulnerabilities, which are everywhere. This is a screenshot that you can basically see where they said, oh, we're going to take the one thing of security that Bluetooth gives us and not do it. And so I read that and I was like, does that mean they'll just talk to anyone? Like without pairing these devices, without any sort of prearranged handshake? And the answer is yes. So this talk isn't supposed to be like highly technical. It's going to be, these guys took this usability trade-off and arbitrarily, we can fiddle with stuff. Oh, one other thing about Bluetooth services and characteristics, they're all identified by UUID. So when you connect to a Bluetooth device, you're usually presented with this barf of hex values that doesn't really mean anything until you like disassemble the app that your device comes with. And you will usually find a table like this. This is Smalley, which is this like halfway Java bytecode disassembly thing from Android. But there's a UUID, and it gets put in a string, and then it gets stored to a variable called the anchor service. And anchor is the ones who made our little Bluetooth beacon, so that's neat. And then there's another string And it gets stored in the firmware version characteristic. So if you have this table, which you can just basically grep out of the disassembly, you can tell exactly how you're going to talk to this thing.
Did you say you can just basically grep that out of disassembly?
Yeah.
Basically?
Well, I mean, you have to disassemble it, and then you have to grep it, and then you have to ignore 90% of the words UUID because they go to other stuff, but it's pretty simple. Can you guys see this? Neat, there's only one button, so it's hard for me to get wrong. Oh, it's bent sideways. Okay. So this is you can see like there's a Phoenix 3 watch, a Gear, I think that's a Samsung. A Tile is actually a device very similar to these, made by somebody else. Oh, Anchor C1, and then some hex data, and now it's doing a Bluetooth 3 scan. And as soon as this completes, we're gonna hook up to one of these and talk to it. Connecting. This is the end of all demo talks that involve wireless. Okay, here we go. Discovering services. So here's a service. Connection failure. Bluetooth Low Energy, especially at the lowest level, like has no real retry logic or anything. So the fact that there's a ton of 2.4 gigahertz stuff in here really doesn't help. And I think we'll try it one more time and then call it a day. I know that's false.
Everybody's trying to hack you.
Okay, device information service. It's got like a manufacturer name, neat. Custom service, that's interesting. It turns out that's the same UUID from that one that we found in the source code. And of note, it has two characteristics that are writable. This first one, which is the second one on the list, that has a W, meaning writable. If you click that, you can write to it. The problem, or that one will actually kill the device and restart it into the bootloader so we can brick it. We're not gonna do that. And then this other one, if you hit R, you can see like, what's the value on this? And it reads 0x0a, and that's just 10. So like we can write stuff back to it. And what's neat about that is that usually when you can write stuff, you can sometimes make it do things. So we'll just send back 0A, and then I'll just hold all these up to the microphone. Did you guys hear that? So that's the same beep that Joel's keys would have made if they were complaining about Joel leaving his keys in the bar. But basically anybody can hook up to do that. Also, anyone can hook up and flash the firmware. Of note, I'm gonna leave these around through the rest of the meeting, but feel free to connect to one of them. Again, the name is ANKRC1. And like you can change the model name because for some reason that's writable, and it's writable by anybody with no Bluetooth permission. So like, if I were feeling like trolling people with Bluetooth, I think what would be a neat little project, it would be to take an ESP32 microcontroller, which speaks Bluetooth like a phone will, and basically scan for devices that have writable device names and just change them to like hacked by SecKC. And there's other silly things you could do with that. But I wanted to say thank you, Mobile T, for letting me borrow this fancy tablet with Android and HDMI, and thank you for Joel for being my friend who puts up with me hacking things when I'm not 100% sure that they're his because it's Bluetooth. Who knows? That's kind of the end of my talk. Do you guys have any questions? I can't see anything, so if you do, you're just going to have to yell them out.
What's the effective range?
Long enough that it's annoying. So when I was trying to track these down, I was actually like walking to the different corners of the room, and I'd like trying to triangulate it with direction finding. So you will take your phone and like shield it from RF with your body, and then turn 180 degrees and see if the signal strength is any better. But it was super unreliable unless I was like in the right half of the room. So I'd say like room scale. They're not very loud radios. The Bluetooth radio in your phone also isn't very loud either. Is that a hand?
Yes.
Speak up.
So
Gonna hold it in until the light turns on.
I'll just yell.
All right, so oh, hello.
Hello.
So you mentioned on the first one that had a W that was writable, that if you did send something to it, you would brick the device. I'm
yeah.
curious how you came to that conclusion.
Science.
So if you find the firmware image for this, and spoiler alert, they basically took the demo kit for the CPU that's on here, and they added this one custom service, and that's like, this is the minimum amount of work to make a viable product, because the chip supplier for this is actually really good at what they do. And they make it really hard to screw up, because like they have demos of how to implement security properly for everything. But if you take the firmware and you change some words around and you change the CRC, you can upload it using the same firmware uploader pieces of the app on your phone, and it'll totally work and change what the device does. But if you were to do that wrong and say change anything other than an ASCII string that's really easy to identify, it's really easy to break devices like this. Like if you change anything in the path from the device turning on, booting up, turning on the radio, and getting back to the firmware uploader. You guys want to see let's try this. Are we still connected? That's amazing. Nope. Oh, no. Because hex. And at this point, like if this works, the app is definitely not going to like this because the device just died. Like, it didn't tear down the connection or anything. Anchor boot. So that's the bootloader string that you want to see if you're talking to the bootloader and not the actual firmware image. And that's where you go to upload a new firmware image. Does that answer your question, Invisible Bill? I think that's Bill. I really can't see anything, just spotlights. Anybody else?